Hey everyone, good evening all. So my name is Muhammad Amir Hussain. Here I am here to tell about presentation name is recommendation engine on career transition. Moving on to the next slide. So our team members, we would like to thank Mr. Sharath Manikonda sir, who offered us assistance on this project. And we will also like to thank Aniket Annam, who guided us. Moving on to the next slide. These all our team members: Akash, Satish, Shahir, Tejaswa, Aditya, Abhishek. Moving on to the next slide. Paushali, Shrikant, Divya Polana, and myself, Muhammad Amir Hussain, Kanimozi. Moving on to the next slide. Swapnil, Sanket, Muhammad Yaqub, Rishi Kumar, and last Sanket Power. Moving on to the next slide. Let me talk about content. Overview and scope, objectives and constraints, technical stacks, project architecture, data collection and description, data understanding, model selection and building, deployment, conclusion, last, references. Moving on to the next slide. Let me talk about project overview and scope. What is overview? The project aims to recommend career paths to freshers to the recommendation system. We see freshers find it confusing to choose their future path. So this recommendation system will help them choose their proper future today. After analyzing the pattern from the data, the project will recommend the best career path to the fresher. And moving on towards scope, the recommendation system based selection of career path can play a vital role to reduce stress for selecting the appropriate path for an individual. Also, it can help freshers to know in which field they can excel according to their skills and interests. Moving on to the next slide. From here, Shrikant will continue.
Thank you, Amir. Our business objectives are to minimize career dilemma among freshers, graduates regarding future job or higher education prospects. And our business constraints are there is frequent sector change among professionals, and there is scalability problem because we don't have enough data. The model is not aware of all known jobs and all sectors in higher education. Next slide. Technical stacks. We use Python as programming language because it is a high-level programming language and it has English-like syntax. We can use Spider as an IDE. It is an open source scientific programming in Python language. And we can use Jupyter as an IDE. It is an open source web application that allows data scientists to create and share their code in the form of documentation. And we can use Google Colab as an IDE. It is a free Jupyter notebook environment that runs entirely in the cloud. Next slide, please. Libraries. NumPy library is used for mathematical operations, and we can use Pandas library for data manipulation, and we can use Matplotlib library for data visualization, and we can use sklearn for machine learning applications, and it is lot useful in statistical modeling, including classification, regression, clustering, and demonstration. And we can use SciPy library for scientific calculations and technical computing. Next slide, please. Web frameworks. We can use Flash to build web application, and we can use HTML to structure a web page and its content, and we can use Heroku for deploy the model in the cloud. And next slide, Paushali will take over.
Hello everyone, my name is Paushali Nag. Today I am going to walk you through our project architecture. So first of all, we collected our data through Google Forms in the form of surveys, and then we converted into a structured format as in Excel workbook, and then we moved on to a whole data cleaning cycle, which involved importing data, then merging data sets, then rebuilding missing data, which involved which involve imputation as well as dropping of missing data. Then we moved on to deduplication. We removed all the duplicates. Then we reduced the errors by removing punctuations and converting all the data into lower case. After that, we moved into the EDA part, where we involved statistical analysis and visualization to gather insights from our data. With the help of Python libraries such as Matplotlib, Pandas, AutoEDA libraries such as Pandas profiling, and also with the help of visualization tools like Power BI. After that, we moved on to the model building part, where we used content-based filtering to build our model, and we collected the data as the document was as a Word document, the categorical features, and we made into a TF-IDF features in the numerical form. After that, we mapped the vectors with the help of sigmoid kernel to get the top end recommendations. Finally, we deployed our model through Flask into a open cloud server, Heroku. So that was our whole project architecture. Moving on to the next slide. As I already told, our primary source of data collection was surveys. We collected data through Google Forms based on our requirement. Next slide. From here, Aditya will take up.
Hi, good evening all. And after getting the problem statement, we mainly concentrate on the what type of data we had to collect from the student and working professionals, and as well as the PG students. And so we taken attributes like name, gender, UG stream, UG specialization, interest, skills, UG percentage or CGPA, certification title, working, job title, and post graduation. And these are the features we have collected from the people. And next, after collecting all these data, we have passed that data through the sigmoid function to get the corresponding recommendations. And we mainly concentrate on skills, interest, undergraduation, and UG specializations. And these features are mainly used in our model to get the accurate recommendations. And next, when coming to the data preparation, we collected the data from the primary source. So we get unstructured data, and we had null values, outliers, duplicate values. So in this phase, we mainly concentrate on those aspects: data cleaning, outlier analysis to remove the outliers, data pre-processing, and NLP is used on the skills and interest features, and TD, DF, IEDF factorizer. And then we converted that into the pandas data frame. Then we passed that to the sigmoid function. And next, my teammates Swapnil will take care of.
Good evening all. I will take you through the exploratory data analysis part. Market analysis involved gathering data from sources and drawing insights from it. Data cleaning involved cleaning of entries, making manual entries to one particular keyword, for example, b.tech to btech. After cleaning, we tried to visualize the data set. Libraries used for visualization are pandas, numpy, seaborn. In visualization, we draw insights from the data, for example, most opted courses by the students. Next slide, please. These are the two bar charts, bar plots. The first bar part is for the UG course done by the people. Clearly, BTech is the favorite choice for the undergraduate studies, followed by the BSc and BCom. In next bar plot, this is for the UG specialization done by the people. Here, clearly, computer science engineering is the favorite choice. Next slide. We also used Power BI, in which we created an interactive dashboard which involved few of the visualization. Here we involved pie chart for the gender, density plot for the CGPA, simple table for the UG streams, top 10 interest of the students, and a donut chart for the certifications. Next slide. So Satish will take care from here.
Hello everyone, myself Poshalina. Now I'm going to take you through our model selection. So we use content-based filtering to build our recommendation engine model. So what is content-based filtering? Content-based filtering is about extracting knowledge from the content. In a content-based recommender system, keywords are used to describe the items and a person's profile is built to indicate the type of choices the person makes. In other words, these algorithms try to recommend career choices that the people having similar history have made. Next slide. So TF-IDF vectorizer. We use TF-IDF vectorizer to to convert our categorical features into numerical features. So TF-IDF stands for term frequency and inverse document frequency. So we convert a collection of documents to a matrix of TF-IDF features. Here in TF-IDF, TF stands for term frequency. So term frequency is the number of times any particular term T occurs in a document. And IDF is a measure of how common or rare a term is across the entire corpus of documents. In our case, the entire corpus of documents is the past career history of the students. The TF-IDF IDF formula is IDFT equal to 1 plus log n by DFT. Next slide. So after building the model, we used the sigmoid kernel matrix to evaluate our model and map the recommendations. The sklearn matrix.pairwise submodule provides us with this sigmoid kernel matrix. Kernels are measures of similarity, like distance-based similarity. So if objects A and B are considered more similar than object A and C, then distance of A and B is greater than distance of A and C. The function sigmoid kernel computes the sigmoid kernel between two vectors. It is defined as kxy equal to 10h gamma x to the power t gamma plus r, where xy are the input vectors, gamma is known as a slope, and r is known as the intercept. Next slide. From here on, Shahid will take up the codes.
Good evening all. Now I am presenting the coding steps followed throughout this project. Initially, we imported the necessary libraries like NumPy, Pandas, and all. Then we imported the dataset DF initial dataset. Then done the EDA and visualization by Pandas profiling and also by using Power BI. Then started data preprocessing. In data preprocessing, initially we'll deal with the null values, then cleaned the data set. And after that, the initial data set DF, we extracted into the job data set, master's data set, and student data set by the following codes. These are the three codes we used for extracting the like job data set, master's data set, and student data set. Next slide, please. So this is the core area of our project, that is the model building. We done the model building by content-based similarity. So initially, the new user will input the details like his UG specialization, interest, skill, and everything, and that is like inputting by a dictionary by an append operation. Now we know that by an append operation, the element will be, or the row will be going to the last row. That's why we can say that the code for that element will be df.ilog of -1, colon. Then we started doing the NLP for cleaning the whole data set. We know that there are many like punctuations, comma, and everything are there. So we have to clean the data set by using regex and all. Then we have to convert it into the like numerical format. Then only we can do the model building. That's why we done the TF-IDF vectorizer. And by using TF-IDF vectorizer, we got the sparse matrix. Then in order to visualize, we are converting to that pandas data frame, and we given the name as DF TF-IDF. Then finally we are splitting the DF TF-IDF vector, not like DF TF-IDF data frame into the job, master, student. That is, we are extracted from DF TF-IDF into those job DFIDF dataset, master's DFIDF dataset, and for new user DFIDF dataset. In new user DFIDF dataset, you can see I used the -1, which means the last row. So next slide, please. So again the student have to select which one he want, whether he want job or not. If you want job, the Y will be assigned by DF TFIDF J, or if you want masters, the Y will be assigned by DF TFIDF M. Then we are moving to the sigmod similarity checking. The sigmod similarity checking will be it will compare between the DF TFIDF for new user comma y in the sense it is job TFIDF or masters TFIDF with respect to the user input. Then if you are then after while we are passing these two inputs into sigmod kernel, the sigmod kernel will trigger the output to 0 to 1 value. If the value is nearer to 1, it indicates that the similar recommendation is giving, or if the value is nearer to 0, there is no similar recommendation. So finally the recommendation will be given by the above sigmod score. This all are about the coding part. Then the next slide will take by Sadish. Moving to next slide.
Good evening all. With respect to deployment strategy, we used Python Flask API, which is an open source platform for developing the web-based application. For front end, we used HTML and CSS. So HTML is an hypertext markup language, and CSS is a cascading style sheet. So HTML will provide a outline structure of the web page, and using CSS, we can give the styling part to the HTML page. Next slide, please. And for deploying the web application in globally, we used Heroku, which is an cloud platform for deploying the web application, which is used for this project. And for getting the files to Heroku, we used GitHub, so which is kind of a storing platform where the required files for Heroku can be stored. And once it is stored, we can link it to Heroku directly. Next slide, please. For front end, we need to get the data from the user, so which can be processed in the backend. So for that, the front page is designed using HTML. The basic structure of HTML is given. All the heading contents and the CSS scripts are given in the head tag, and all the input and output tags can be given in the body tag. Once everything is done, the CSS can be used for giving the color and the images and changing the font and sizes. Next slide. This is just an example of the application of CSS and JavaScript. So initially, by using only HTML, we get a outline of a page. By using CSS, we can get the very good picturization of the page, and we can make the page dynamic by using JavaScript. So these all things are used in our front-end part. Next slide, please. So with respect to Flask API, we created a main Python file, so which interconnects the front-end HTML part and the back-end Python machine learning model. And in addition to that, we need an Excel dataset for getting the data for calculation. So once everything is ready, we can copy the file. We have copied the file in the GitHub. So the major files required for Heroku, which is placed in GitHub, are the main Python file, so that links the front end and back end, and the Python model file, which is for processing the data given by the user, and HTML file for the front end for getting the data from the user, and the Excel dataset for processing the data. And requirement file is needed for installing the required packages in Heroku, and the proc file is used for mentioning which function should be accessed by the Heroku in the main file. Next slide, please. So this is the front end page of our website. So here the recommendation type is given by the user, which can be job or higher studies, and the name is for just entry purpose. And major entry required for our calculations are UG degree, UG specialization, skills, and interest. So once user enters the details and submit, the data will be transferred to the backend Python code where it will be processed, and the output results will be again sent to the front end part and will be displayed in the same page. Next slide, please. So now we can see the deployment, the part in the web browser.
Yeah, if you see here, we have to enter the job or higher studies recommendations type. So I am selecting job here and giving my name and selecting UG degree as Bachelor of Engineering and UG specialization in computers, and skills is Python, SQL, and C, and interest will be data analytics and data science. After submitting, we'll get the regarding recommendations, what type of recommendations we'll get on the job. These are the recommendations that we have get by entering the details.
So next slide will be explained by Rishi. Thank you.
Hello everyone. So in conclusion, I would like to say that the recommendation engine helps the students in choosing the best career path and clearing the confusion for the freshers in choosing their career. So the key points considered in building the recommendation engine is UG specialization, interests, and skills. So next slide. So these are some of the works from where we took our references from. So a career path recommendation framework from Bharat Patil, implementation of an automated job recommendation system based on a candidate profile by Vijay Kolekar, recommendation system for predicting students' performance. So next slide. So schematic matchmaking for the job recommendation by Fazel Zardani. A framework for career education hybrid recommendation system using a selective path algorithm by Baladin. A new content-based job recommendation algorithm for job seeking and recruitment by Nicholas. So these are the references. Next slide. So this is the end of our presentation. Finally, I would like to thank once again all of our team members and mentors for making this project happen. So any questions? Okay. Thank you all for your time. Thank you.
Yeah. Hi and good evening, everyone. Myself, Khushi Agarwal. I would like to take the privilege to thank 360DigiTMG and Datatics for giving us an opportunity to work on the project to build a recommendation engine for final year students for ideal career path. Next slide. I would like to extend my thanks to our team members, team mentors, Mr. Sharath Manikunda and Mr. Anikit Anand for extending their support and guidance throughout the course of the project. Next slide. Here I take an opportunity to introduce my team members who have worked to successfully complete this project. The team members include Sandeep Patnaik, Sangeeta Patnaik, Chaitra Chachari, Vicky Maharana, Meena Vaishali R, myself, Bakaran Niharika Reddy, Irfan Muhammad Umar Ansari. Next slide. So now coming to the contents of the project, it includes project overview, project scope, objectives and constraints, success criteria, CRISP MLQ methodology, technical stacks, project architecture, data collection, data understanding, data pre-processing, a model building, model deployment. Now my teammate Meena Vaishali would take up. Thank you.
Thank you, Khushi. Okay, my name is Niharika. Okay, sharing the insights of a project, the student career recommendation system can be used by the student to select the best suited career path based on their UG course and specialization skills and interest. Nowadays, the number of related study fields are available, which makes the students confused to avoid their problems. We deployed this recommendation system. The system will recommend only on the basis of student responses. Moving on to the next slide. Okay. The focus of a project is to guide the student to choose the right career path based on their skills and interest. Many students are choosing their career path without having complete knowledge. This may potentially cause mismatch between academic achievements, personalities, interests, and capabilities of the students. The recommendation system takes the inputs from the students and recommends the career path accordingly. Moving to the next slide. Okay, let's discuss the objectives. With the definition of objectives and understanding of business requirements is to build a career recommendation system that can be used by the student to select the best suited career path based on their UG course and specialization, skills, and interests. Focusing on the prime objective of this project was to maximize the accuracy of the system and minimize the mismatch recommendations. Moving on to the constraints that occur during the course of the project, that the data collected doesn't compromise of all the PG or higher education programs and their specializations, and all kinds of jobs available in market scenario. Time constant was also one of the major constants due to which maximum data was not collected. Okay, the next slide will be continued by Meena Vaishali. Thank you.
Hello everyone. So I'm Meena Vaishali. I'm going to explain success criteria. So insights on success criteria. The career recommendation system will be helpful to select the best suited career path based on the UG course and its specialization, skills and interest. So these days, there are a lot of related stuff available, which makes the students confused. So this software will be recommended on basis of students' responses. Moving on to next slide, CRISP-ML methodology. With the definition of objectives and the understanding of business requirements, as well as general and technical situations, after the project fundamentals and goals are defined, the data is analyzed in the data understanding phase. So this phase includes selection of a data set and the analysis of its attributes and structure. When a suitable data set is found, the data is first cleaned and then the data engineering part is done and then prepared for modeling. So in the modeling phase, a modeling technique is selected and applied to the data set. The created model is then assessed, and if it meets the requirements, it is evaluated. When the developed model is ready to be deployed, the IT environment into which it will be deployed needs to be analyzed in the deployment phase. Before the deployment, Monitoring and maintenance can be planned to be monitored and validated to ensure the high quality. Moving on to next slide. Okay, let's check on with technical stack of this project. So here we have used Python. It is a high-level general purpose programming language. Its language constructs an object-oriented approach aimed to help programmers write clear, logical code for small and large-scale projects. Next block refers to IDE. IDE stands for Integrated Development Environment Platform. The IDE that have been used include Spider, Jupyter, PyCharm, and Tableau. Spider is an open source cross-platform integrated development environment for scientific programming in the Python language. Spider integrates with a number of prominent packages in the scientific Python stack, which includes NumPy, SciPy, Matplotlib, Pandas, Seaborn, Scikit-learn, StatModel, which are the packages which is used for iteration utilities. Jupyter Notebook provides you with an easy-to-use interactive data science environment across many programming languages. PyCharm is an integrated development environment used in computer programming, specifically for the Python programming language. Tableau. Tableau Public is free software that can allow anyone to connect to a spreadsheet or file and create integrative data visualization for the web. Web framework that was used in this project is HTML. HTML for developing the structure of the website to take inputs manually from the user. Heroku. Heroku integrates with GitHub to make it easy to deploy the code living on the GitHub repository. Streamlit. Streamlit is an open source Python library for creating and sharing web apps for data science and machine learning projects. Moving on to next slide. Yeah, which is a project architecture. The most crucial part of the project, it is an architecture. Understanding the business objective and eliciting requirements from the client. Based on the client inputs, the data is collected in two different ways, primary and secondary. So we have done both in primary and secondary source in this project. So primary source, recorded responses from the Google form, and secondary source is market research work. Next, we proceed for the data extraction and data understanding. So this includes the selection of data set and analysis of its attributes and preparing the structured format. After all the earlier mentioned steps are performed, then data pre-processing is taken up to. It includes data cleaning, exploratory data analysis, feature engineering, and data visualizations. Heading towards model building by using the planned technical tasks, and finally developing the build model with the help of different deployment techniques. So I'm calling Chaitra to explain her part. Thank you.
Thank you, Meena. Good evening, everyone. Coming to the data collection part. Data collection is the process of gathering, measuring, and analyzing the accurate data from variety of relevant sources to find answers to research problems, answer questions, evaluate outcomes, and forecast trends and probabilities. The primary data collection was done through Google Forms. Coming to the data understanding part. Data understanding is the knowledge we have about data. The needs of the data will satisfy and its contents. The data set consists of 1195 responses and 12 variables or features recorded in the table. Name of the feature, description of the feature, name of the type of the variables. All the types of variables that are present in the table are of categorical data types, except the CGPA column, which is of continuous data type. Moving on to the data pre-processing part. There are four steps for data pre-processing for the data building. The first step is data cleaning. In this step, we clean our data as per our requirements in order to get meaningful insights. Here, we have checked for the duplicate values and removed it accordingly. Second step is data integration. Here we have combined the data from multiple data sources into single unified view. It brings together data gathered from different sources and makes it more valuable for your business. Further, it gives a uniform view of scattered diagrams and also helps in maintaining data accuracy. The third step is data transformation. This step is involving conversion of the data from one format to another, typically from the format of a source system into a required format. Fourth step is data reduction. It is a process that reduces the features from the original data to represent it in the compressed volume. In other words, It takes the most meaningful and important features among all. Next will be continued by Sangeeta. Thank you.
Thank you, Chaitra. Good evening, everyone. Today, we have obtained data from pre-processing. Further, we separate them into two data sets, job and higher studies. For job, we have considered UG stream, specialization, interest, and skills. For higher studies, UG stream, specialization, and interest. Based on this, we have recommended job and higher studies accordingly. Next slide. Moving to data cleaning. As we saw in the above slides, while data cleaning, we have partitioned our data set into two parts, higher studies and job, based on the responder who responds S to higher studies or S to job. Here we drop the rows which have irrelevant and NaN values in both the data sets. Next slide. So here we come to our visualization part. First one is job versus sample data. From the bar graph, we can conclude that out of 13 job types, majority are from data analyst, second highest is software developer, third is design engineering, and the list goes on. Next part of the project will be explained by Irfan. Thank you.
Thank you, Sangeeta ma'am. Hello guys, this is Irfan Ansari. Now see the EDA, PG and sample data. From this bar graph, it can be easily interpreted that most of the aspirants have chosen MBA and MTech over others. Next slide. In this EDA, interest and sample data. The visualization of interest and sample data from this bar graph, we conclude that the majority of respondents are from the technical area. Since we have seen in the above job versus sample data, the top three are from data analyst, software development, and design engineer. In accordance, technology top higher in interest. Next slide. In this EDA skills and sample data, this bar graph clearly concludes that 23 responders are skilled in StatPro, ETAPS, Python, and Scale. 14 are skilled in Python, and 11 are skilled in Python and AI. So we have seen the visualization part of the data. We have extracted features from our data. Next slide, I request Sandeep to take next slide.
Thanks, Irfan. Good evening, all. Let's see the model building part. Since we have the data which is full of categorical values, we use the count vectorizer algorithm, which is a feature extraction model. It will check the stop word vocabulary and will perform a tokenizing. So it will take the parameters as max features. So stop words equal to English, as you can see in the slide. It will remove the basic English words like a, is, we, that, how, and like that. Some words it will remove. And count vectorizer usually calculates the length of categorical value into numerical value. So that we can build our recommendation model on it. Count vectorizer feed underscore transform. As you can see in the slide, count the number of text and print in a transform matrix. And as you can see from the slide, the column tags consist of interest, skills, percentage, UG, specialization, and has been converted into an array for better understanding. Key skills, which will comprise all the rows of the combined feature tags. Let's finally move into the model building part. A recommendation system works based on the similarity between either the content or user who access the content. There are several ways to measure the similarity between dependent and independent items. Here, the recommendation system uses the cosine similarity matrix to recommend the next most similar job or higher studies to the user. Cosine similarity mathematically measures the cosine of the angle between two vectors projected in a multidimensional space. The output value range will be between 0 to 1. If the output is 0, then it means no similarity is there. And if the output is 1, it means 100% similarity. Once our model is working as per the business requirements, we can further proceed with the deployment part. Moving into next slide, please. Here the code we have used in PyCharm has been displayed in the slide for the deployment of the model. PyCharm is basically used to create a web application interface in order to facilitate the user to get their recommendation with the help of machine learning algorithm. Moving into next slide. Here to discuss about deployment strategy for this project. We have used it for this used for data manipulation using Pandas Lib, data pre-processing, data visualization using Seaborn, model building using SQL packages. And last one, HTML. HTML is used to enhance the structure and visual graphics of the web application. Moving to the next slide. Then continuing to the deployment strategy, GitHub is the cloud-based repository to store our code. We will be able to edit the code anywhere and everywhere, and also be able to deploy the committed changes to the cloud by connecting Heroku and GitHub with the respective credentials. And Heroku is a platform as a service, like a PaaS, that enables developers to build, run, and operate application entity in the cloud. I'm calling Vicky to carry further slides. Thank you.
Thank you, Sandeep bhai. Now I will be showing the rest of the slides. The next 3 slides will be show you a glimpse of our web application and user inputs, user type input types in it. The slide we are seeing now is showing the home page of our web application. This page for higher studies, where the user has to put UG, specialization, and field of interest, and he or she will get the recommendation according to that. Next, the slide for job recommendation. Here the user has to enter UG, specialization, skill, and interest in order to get their job recommended. Now I will be showing you how the web page actually works. As you can see, this is our home page. User have to select either job or higher studies from the drop-down list box. Here I am choosing job. Now I will choose the undergraduate program from the drop-down list box. Like I'll be choosing BTech from the list, and from here I'll be choosing computer science engineering. Then let's say HTML. Like JavaScript. Then if I will go for Python, yeah, Python, and CSS. Now we will field of interest. Yeah, we can choose the field of interest from this drop-down list box, like data science, artificial intelligence, and all these things. When the moment the user will click on the submit button, he or she will be get recommended for the respective jobs as their inputs. Same goes for the higher studies also. Now I'll be returning to the slideshow. Finally, on the stage of conclusion. So all of our aim is to empower the students regarding their discussion and their future study plans, and fulfill their expectation to choose their desired platforms. Thank you all for joining and staying connected during this hour on behalf of my entire team.